welcome to the SQL injection module. Lots of exciting stuff here. This is another module where it could take years and years and years to really master this stuff and get it to the point where you can just do it. So I don't expect that new person to be able to just go out there and SQL inject the world. But with a little bit of practice, we'll get better. Okay, so this is another one of those modules where you can have a cheat sheet. Okay, there's lots of different database languages, and so if you're going to go from MySQL to SQL to Oracle, etc., use the cheat sheets. It'll help you remember how it works in one particular language or the other. Also, most database people, they know MySQL inside and out, but they may not know Oracle, or they know MS SQL, but they may not know MySQL. Realistically, it's just databases, and different databases speak derivatives of the same language. It's kind of like if you learn Spanish, it's not too hard to pick up Portuguese or Italian for that matter. Okay, so concepts here. Okay, ultimately you have to be able to analyze between the client and the server, and that all starts with something as simple as an HTTP post request. Okay, this is where we can sniff traffic and analyze that request. It could be a network sniffer like Wireshark or TCP dump, but it also could be like a tool like the Burp Suite to basically dissect this client to server traffic. Okay, if you look at the client talking to the server on a normal conversation, this is what we call normal code analysis. And the pen tester needs to understand what normal analysis looks like, so then they can start deviating from the norms to get the computer programs to basically do what they want. Okay? Ultimately, in database language, this is what it's going to come down to. There are certain parameters like the update parameter. This is when a client sends to the server and says, hey, I'd like to update something in the database. Okay? Or select something from the database where the values are equal to whatever they are. Okay? Or get something from my table. Okay, just a generic table name in that sense. Or just drop the whole field, the record, the row, the column, the database, or the table. Okay, so it's everything about the client to the server. Once you get to the table, once you're in the particular, or the database, then the table, and once you get to the table, then it's the columns, then it's the rows. Okay, so you can kind of think of this hierarchically. Let's talk about some of the attacks. Ultimately, what you can do if you get really skilled at SQL injection is remote code execution. That's good. Also, you can knock the database offline, therefore nobody else can access it. That's an attack on availability. You can use tricks like bypassing authentication, maybe send the admin credentials followed by a single tick and -- which is a comment field, and then comment out the requirement for the password. All right, maybe just get directly into it as admin. A little bit of a dated technique, but nonetheless, in the older days of SQL injection, it was just that simple. Just comment out the password field, and the server would just follow the programming logic. Okay, no password, fine with me. All right. Information disclosure, whatever's in the database ultimately could get disclosed. There are advanced SQL injection techniques, or at least I'll show you the theory in which you can start enumerating database names, table names, column, rows, and then field names or field characters. You can change the integrity of the database and the tables. You can do things like password grabbing. You can transfer the whole database from the server to the client. One of my favorite techniques. One technique, you got the whole database. Or allow the database to interact with the operating system. This is where you can start doing things like pinging and trace routing or any sort of operating system commands typically that you would be able to do at the command prompt. All right. So let's talk about some of the tools. Okay. Does the database exist? Where is it? Ultimately, you need to enumerate that. Okay? Once you find out what database it is, well, then we want to start listing the fields inside the database. We can do some basic injection tests, test it with what sort of input validation is actually present, start doing things like the union command, and then dissect our error messages to see if we can't get any more information. Okay? Some of the traditional attack characters here is the single tick or a double tick. Basically, these are what we call string indicators. You can do comment fields, either like a dash dash or the pound sign. You can do multiple inline comments. This is also great for obfuscating techniques. Okay, you can add the plus sign for like in addition to. You can do pipes, like a solid bar. You can do wildcards with the percent characters. You can add things like and equals one equals one dash dash. Or you can start adding additional parameters into the database query like order by. And then you can start sorting it ascendingly or descending, etc., etc., etc. But while those are some of the basic attack characteristics, let's talk about the basic types. You have blind SQL injection. This is where you're trying to poke and prod the database, but you are not getting any information back. So you really don't know if it's erroring out or not, because the error messages are not coming back to you, the penetration testers. You can kind of countermeasure that with the wait for command and see if the application actually waits or not. But the trick to the wait for command is you don't want to make your timeout so long that you're just sitting there waiting, but you don't want it to be so short that you can't figure out if it waited or not. You have simple SQL injection like the single tick or the 1 equals 1 tac tac and things like that. You have your union command, which basically, this is a great technique because what you're doing is you're sending a query from the client to the server and saying, hey, I'd like this out of the table, and by the way, give me something else from some other table. Union meaning combining from some other table name, or error-based injection. Before we go into the advanced stuff, let's hit the tools. SQL injections got really easy in the last couple of years because of tools like Be a SQL Hacker or SQL Power Injector or Havi or a variety of the other tools that are on the Backtrack or Kali operating systems. All right, so let's start taking apart some of the basics of advanced SQL injection. There are certain parameters that you can add to a URL string, and then you can start guessing things like the user fields or the database names, okay? And it's basically an attack where you basically say if the ASCII, lower, and substrings for the user are equal to 1 and your parentheses and then 97, 98, 99, 100, you can start mapping out. And so this would translate to the character A, the character B, C, D, E, F, etc., etc., etc. So you could keep doing this and start gaining what character and what order that character is in, and then you can start enumerating the database table, columns, rows, names, etc., etc., etc. If you want to go after user accounts, you just go after the user. If you want to go after the database name, you switch that to the database name. They have slightly different syntax, but it comes from the basic construct here. And then you can combine this with the wait for delay, and especially if you're doing this blind, and see if it actually waits for 10 seconds or not. Okay? Or we can go into the evasion techniques, right? Well, if you're going to poke and prod a database, you don't want to do it in a way that's going to set off the alarm system. So the basic way in which we do this is we try to encode or obfuscate or hide our characters. Remember, the security admin or the database programmer should be doing some sort of input validation. So we just need to find out what the rules they put in place are and then start bypassing those rules. Okay, some of the ways in which we can do that is we can take a regular SQL expression and we can encode that in hex. So the input validation may have been done in ASCII but not in hex. If we just encode it in a different encoding language like hex or base64 or something like that, or UTF, in a way that the server-side component's not looking for it, well, then you just defeated their rules. Also, you can put things like inline comments or multiple line comments in between things to help obfuscate, the 1 equals 1. So it'd be like the letter 1 or the number 1, a comment, end comment, or start comment, end comment, one, and so you got a bunch of comments in between that. So realistically, the person writing the code there would probably think, why would anybody construct the statement like that? Well, you're just obfuscating and trying to bypass their input validation filters. Or you can use character encoding, which is one of my favorite techniques. It's a little bit lengthy to do that, and it does require you to think in character language. But after a while, you can start thinking in 47, 32, 117, etc., 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 and then you can start writing these. It's kind of like the Matrix. After a while, you just see the code. After a while, after a while, you just see the characters. Okay, but it's a great evasion technique because realistically, the person that wrote the input validation filter on the other side, they had really better thought all of the possible ways to try to prevent me from doing something like this. So if you get really, really good at SQL injection, you can try to stop me, but good luck. Okay, if you were to try to stop me, here's the types of things I would hope you would do. I would hope that you would set minimal privileges on your database, because if your database is tied to a super user account and I get access to it, I am now going to be executing things as a super user. So hopefully you have the concept of least privilege in place. That way, if I do get access to it, I get very, very little as a result. Hopefully you don't allow me to interact with the XP command shell. That cuts off half of the things that I can do in terms of interacting with the operating system, doing things like pinging and trace routing and ipconfig and things like that. Hopefully you're suppressing error messages. The more information I get in terms of error messages, hey, table so-and-so not found. Well, now I know your table name. Okay, so if you suppress those error messages or use custom error messages, that's much better. Actually monitor your database. See who's accessing it. How many things are getting put into it. Are you even backing it up? These are all really, really good ideas in terms of countermeasures to prevent me, the penetration tester, from getting access to your stuff. Hopefully you're filtering content, right? Hopefully you have snort rules that flag for base 64 encoding. Because at least, that if you are doing that, well then I would have a hard time avoiding the alarm system from going off. Also, test your code in a secure environment. I would hope that you would be doing this by now, but it still never ceases to amaze me that people just don't test their code. The developers write their stuff, they make changes to live databases, and then someone, comes across and exploits your stuff. One of the best examples to do is go to Google and search for vulnerable SQL injection sites and then whatever the year you're looking for. And somebody has already compiled a list of all of the websites that they have found that are basically vulnerable. Act ethically, don't go penetration testing and testing on a live site or somebody else's stuff. We got to act ethical here. Nothing is worth your own integrity. You should also be using URL scan. Right? Scan the URLs, see what goes back and forth. Use the tools and use things like URL scan. And then some good intrusion detection rules as well. The reason why I chose snort rules is because, one, the guys over at SourceFire, they do a phenomenal job. And then two, learning how to write your own intrusion detection rules is good, because if basically you know exactly what you're looking for, you can write your own rule for that and update your own snort rules. All right, so you do have to kind of have some sort of intrusion detection or intrusion mindset, but notice the problem here, right? You have to, defensively, you have to have an intrusion detection mindset. You have to have a code developing mindset. You have to have a programming mindset. These qualities in one single person are very, very rare. So now you, defensively, you have to have a team of people just to stop a person like myself, all right? So in the world of SQL injection, since we're all connected with database these days, it is not that hard for me to start poking and prodding websites. It's actually relatively easy. Plus, there's a lot of tools that are out there that basically are point and click script kiddie stuff. So with a little bit of script kiddie mentality, plus some insight to how databases work, and combine that with even more insight with the different types of databases that are out there, I mean, the penetration tester is virtually unstoppable at this point, especially when you get into the advanced SQL injection techniques. So you want to add value to yourself, you want to add value to your career, you're going to have to be able to dissect this stuff. And the rules of making money are, you got to deposit into the bank before you can withdraw into the bank. Here, same thing. You have to secure your code to prevent someone else from getting access to your code. So keep that in mind, and let's look at some examples.